So for the second part of 5.1, we're going to be looking at how to find probability using a normal curve. Now I'm going to go over 3 methods. Okay, so make sure when you're doing your quiz test, you're reading the directions. Each method, the answers might be slightly different due to rounding and how accurate each method is. So make sure you're reading the directions carefully and you're using the correct method, the method I ask you to use. The first one we're looking at, 6895 9.7 rule. Okay, this is also called the empirical rule. Now what this does, this is cutting up our normal curve into sections, and then I'm going to tell you how much each section is worth percentage-wise. Okay? So we have our normal curve, and we're going by these percentages up here, 68, 95, 99.7. And remember, the average is in the center, and standard deviation is showing us how wide or thin our curve is going to be. Well, the standard deviation is what we're going to count by. Now what the rule says, within one standard deviation, I abbreviate as SD, the mean is 68%, okay? And what this means is we are going to be 68% of our distribution is within that interval. So if we have our average in the center and we start going -1 standard deviation, +1 standard deviation. Now you have to kind of pretend those are symmetrical. I know I'm not perfect measuring them out or anything, but if they were symmetrical, within -1 and 1 standard deviation is 68%, which means each of those sections is 34%. Okay? Okay, 34 is giving us our 68%. Now if we keep going down the rule here, there's 1 standard deviation, the 95 is our second standard deviation. Within 2 standard deviations of the mean is 95%. So I'll make a couple more lines here. -2, that's +2, and we already have 68%. So it's not like we're just cutting 95 and putting part in here, part in here. We already have our 34 and 34. These two sections between -2 and +2 is 95%. We already have 34, we already have 34. The next two is 13.5%. So then we just keep on going down, okay? Now we're going to have 99.7 was within 3 standard deviations. -3, +3, I'm sorry, I don't know why I made that a solid line. Keep it consistent, okay? And now we have 99.7. You can see the size of the section is determining how much percentage is being taken up here. So 34%, those are the biggest sections. Gets smaller because the curve's going down. The width should be the same. Okay, again, I'm not perfect, I'm not measuring out. These should be the same width. We're counting by a constant of what the standard deviation is. Okay, so the percentage, if we go 34, 13.5, we have to have that section. They all have to add up to 99.7%. We are at 2.35%. Okay, and now all we have left is the tail. And in the tail is that last 0.3. Remember, the whole curve's 100%, 99.7, so that's 0.3 in those two. So if we cut the 0.3 in half, it is 0.15, 0.15. Now, if you can remember those percentages, okay, we're going to use our average and standard deviation to set up what these values are. These are considered standardized. Okay? And it's standardized because our average is at 0, and we're just counting by how many standard deviations away. 1 standard deviation, 2 standard deviations, 3 standard deviations. Okay? In our problems, we're going to be given situations where we know what the average is, we know what the standard deviation is, we know the parameters. Knowing those parameters, we can set up the curve and then use these percentages. Okay? So take a second, kind of sink in where these numbers came from using these percentages here. Okay, kind of knows what the name is, and let's look at some examples. And so here's the setup. The average person eats 32 wings during wing night. There is a standard deviation of 3 wings. That's the parameter of our situation. Okay, that's what our population does. People who go to wing night average of 32 wings, standard deviation of 3. So with that, we can set up our normal curve. Okay, we know that we have 32 as our average, and that's on be our center. Okay, average is always on be center, and we go 3 standard deviations to the left, 3 standard deviations to the right. And then what numbers we're going to put down there, we're going to count by standard deviations. So since our standard deviation is 3, we're going to add 3 each time to get our line. So we start at 32, plus 3, plus 3, plus 3. 32 plus 3 is 35, plus 3 is 38, and 41. Going the other way, just like a number line, we're going to subtract. Minus 3, minus 3, minus 3. 29, 26, and 23. And the percentages we had before, those will not change. So if you just want to quickly put in 34, 13.5, 2.35, and then 0.15. Okay. Those are the percentages those percentages will not change. These numbers down here will, depending on our situation. Now, the types of problems you're going to see, I'm going to ask you about picking random people. What's the chance that a person eats between 35 and 41 wings? Well, you just need to look at where that 35 to 41 is. Here's 35. Here's 41. Anything between those 2 green lines, since it says between those 2 values, that's our percentage. 13.5, 2.35, if you add those up, 13.5, 2.35, 15.85 is our percentage for that one then. Okay, so as long as you have it set up and you find the correct lines, you can then add up your percentages. What's the chance of eating less than 29 wings? Well, let's see where this one is. 29 is here. Okay, now remember that line represents the 29. Less than is everything going down. So it's 1, 2, 3 sections we would have to add up. 0.15 plus 2.35 plus 13.5. Add those up and you get 16%. Okay? So the setup's important. Knowing those percentages are important. After that, just seeing where those lines are asking about, what the question is asking about, then you can add up your percentages. Now, one downside to this method, what's the chance of getting between 23 and 36 wings? Well, 23, we have here, we have that on our chart. I'll do this one in red. But the 36, that's not on our chart. That's not one of the numbers that falls directly on a standard deviation. If you're counting by standard deviation, you'd have to estimate. Okay, you'd probably be right about there somewhere. But now we're not going through the calculus to find that exact area. We're not getting that detailed. Unfortunately, with this method, you are limited to using only these 7 values that are on our chart that we can count by 3 standard deviations in both directions. Okay, so that is one of the downsides. So there's our first method of finding probability using the normal curve, the 68, 95, and 99.7 rule.